Hi guys, I'm Aravindan from Tamil Nadu. So I have been part of EV101 course and now currently in the process of EV201 course. So here I'm going to explain what we have performed in this course. So we started by making a small motor with this copper coil, a battery and two pins. So how this works is we have stripped the ends of the copper coil only by half the side, so that only half of the side will come in contact with the pin and let the current pass through. So when the current pass through, it will create a temporary magnetic field and there will be a magnet here. So it will repel and it will start to rotate, and with that force it will complete one revolution, and again it will come back it will complete one rotation and it will again come back to contact in the half stripped side, and again it will create a magnetic field and it will rotate in this way. So this is the basic version of a motor we created to understand how a motor works. The problem that I faced while creating this version of the motor is, first I created a thick coil with a smaller radius. Hence the magnet was not able to give enough force to rotate this coil. Later I made a thin coil with a larger radius and the magnet was able to give enough force, so the motor rotated successfully. Later, we created a model, this model, where we first used a MOSFET to power the coil. So the MOSFET is like a switch. So it has a source and a drain. So when power is supplied to the MOSFET, then it will allow the current to pass through the output, and the output current will activate the relay and the power will supply to the coil. In this way, the coil will generate a magnetic field and it will attract the magnet, and the next coil will attract the magnet, and it continues and the rotor rotates. Now we have the motor up and running. Next we will learn to build a battery management system where we will be um, reading the temperature, voltage and current of the battery pack. We have used LM35 sensor to measure the temperature and 5 amp current sensor to measure the current, and we use the capability of the Arduino to read analog signals to read the voltage from the battery. Since we have used 4 AA batteries, the combined voltage will be 6 amp, and Arduinos can only read signals till 5 amp. So we introduced a voltage divider using resistors to reduce the voltage that goes into the Arduino, and in the code we will be using a formula to calculate the real voltage of the battery. In this way, we have built the battery management system. In real electric vehicles, the BMS used to communicate with the motor controller and the charger to communicate its parameters like voltage, current, and the capacity to charge and discharge efficiently and safely. Since here we don't have a charger, we will be communicating the BMS with the motor controller to send its parameters. Here we have used like I2C communication, in which the SDA and the SCL pins, which are A4 and A5 for the Arduino Nanos, are connected and made the ground common. In this way, the serial clock SCL is used as a reference point to transfer the data in the SDA serial data line. In this way, the data like current and temperature are sent to the motor controller to stop or start the motor. Later, we have learned to simulate the motor model in the FEMM software to um, calculate the amount of torque that can be produced by the model. And we have also learnt about different types of driving cycles followed by different countries to calculate the fuel consumption and efficiency of the vehicle. We have also studied more about the functional and safety standards available for the electric vehicles. It was a fun, interesting, and practical learning journey. Thank you.